Hi, welcome to section 1 of Unit 3. Unit 3 is all about polynomials, and we're going to start with the simplest ones, which are linear polynomials. And these are going to be functions that graph as straight lines. Okay, now one thing to know is that linear functions can always be written in the form f of x, or whatever you're naming your function, equals mx plus b. And sometimes you'll hear this called slope-intercept form, or just y equals mx plus b. And we'll see why that form is really helpful, because then you can easily know the slope and where it intersects the y-axis. Now, if the slope is 1 and the y-intercept is 0, then it's just f of x equals x, and that's called the identity function. Let me show you what that graphs as. So if we just graph y equals x, that means you're putting in a value and you're getting out that same value. And it graphs this straight line that goes straight through the origin, kind of at a 45-degree angle. Now, if our slope is 0 and we just have f of x equaling any number, then it's called a constant function. And it's actually going to be a horizontal line, because no matter what number you plug in, you get out that number, the constant, that b. So let's say it was 6, just f of x equals 6. Well, this is going to be the horizontal line that's up at 6. So no matter what x value you can plug into this function, think about it like a machine, any x value you plug into that machine, you're getting out 6, no matter what. Now, we're not going to talk about vertical lines because they're not actually functions. They fail the vertical line test. That whole line would intersect it in more than one place. Now, one thing we have with a line is its slope, and slope you can kind of think of like the steepness. Whether it's positive or negative will also tell us which way the line is going. If it's positive, it'll be going up from left to right, and if it's negative, it'll be going down from left to right. Okay, so you might have heard slope called rise over run. What it really is the change in the y divided by the change in the x. And we have a formula here. If we have 2 points that we're calling x1, y1, and x2, y2, then the slope is y1 minus y2 over x1 minus x2. And in other books, you might see it as y2 minus y1 over x2 minus x1. As long as you keep either the 2's first or the 1's first, it really doesn't matter. So if you've seen it that way before, that's okay too. Now, just to look at what happens with slope, let's go to this y equals, and let's put in y equals x like we had before. We'll leave that one just regular. 2x, we'll give that one a dotted line. Where's our dotted line? There it is. Okay, and then 3x, we'll give that one a bold line. Okay, let's graph these. So there's y equals x. That would just have a slope of 1. There's 2x, and there's 3x. So, you could kind of put in your own words here what's happening, but as the coefficient of x, so the number in front of it is also called the coefficient. Here it happens to be the slope. As the slope gets bigger, we can say the line gets steeper. Okay, and when it's positive, remember it's rising from left to right. It's increasing on the whole domain. Okay, now we're going to use our calculator and we're going to look at some negative slopes. So in y1, we're going to put negative 0.5x. In y2, we'll put negative 1x, which we don't even have to put the 1. And in y3, we'll put negative 4x. Now, like I've said, the negatives means it's going to be decreasing. So they're going to be flipping and going the other way. Okay, there's our negative 0.5. There's the negative 1. And there's the negative 4x. Okay, so again, now they're decreasing. But as that absolute value gets higher, they get steeper. So we're going to talk all about how to find the slope, how to find equations of lines, how to graph the lines, all sorts of things. But this is just kind of an introduction of what that slope looks like and slope-intercept form.